Good evening, children. So, back to chemistry class. Today we shall learn how to name a chemical compound if a chemical formula is given to us. So, naming of the chemical compounds for today. First thing, if a compound contains only two elements, if a compound contains two elements, right? That is, one is a metal and the other one is a non-metal. Then how are we going to name them? First, the name of the metal will come, followed by the name of a non-metal with the suffix "ide" at the end. Let's take an example like NaCl, okay, or maybe Mg3N2, or another example we can take as CaO. So what did I say? A compound. These are compound which contains two elements. What are those two elements? Metal and a non-metal. A metal and a non-metal. A metal and a non-metal. A metal and a non-metal. So how to name? First we write the name of the metal, that is sodium, and then the name of a non-metal with the suffix IDE, with the suffix IDE over here for a non-metal. So it is chlorine. What do we write over here? Chloride. So the name becomes sodium chloride. Come to the next one. What is the name of this metal? Magnesium. Magnesium. This is nitrogen. It has to end with ide. So magnesium nitride. Calcium. Calcium. It is oxygen. Has to end up with ide. So calcium oxide. The first is clear. Then the second one. If a compound has two nonmetals. If a compound has two nonmetals, like for example CO, CO2, or maybe SO2. So here how are we going to name? First we write the name of the element which is in the left side, right, in the molecular formula. Then write the name of the other element and end up with again what? Ide. Let's do that. What is the element at the left side? Carbon. Carbon. Now here we need to also write down the prefix like mono, di, tri, something like this. So here only one carbon is there. So what do we write here? Carbon monoxide. Okay. The prefix used over here is mono. Mono means one. Similarly, carbon. Carbon. How many oxygen? 2. So for 2, what do we write? Di. Di means 2. Carbon dioxide. Followed by this sulfur. This is S. L stands for sulfur dioxide. Let me give you one more example. PCl3. These two are non-metals. How do we write? P stands for phosphorus. Right? How many chloride or chlorine atoms there? 3. So we write phosphorus tri. Then chlorine changes to chloride. Followed? Same way you can also say PCl5. How are we going to name it? Phosphorus 5 means penta. Phosphorus pentachloride. These two are clear. We next move to the third kind. What is the third type? The third type is if compounds contain three elements. if the compound contains 3 elements, then what? Then suffix ate or suffix ite as per number of atoms present in the compound have to be mentioned. Let's take examples over here also, like NaNO3, compound containing 3 elements, NaNO3. Clear? So how are we going to name this? Take another one like NaNO2. So both this will come over here. How do we name this? Sodium. What is this? For more number of molecules of oxygen, more number of atoms of oxygen present, we write sodium nitrate. 8 is written when more number of oxygen is present. Ite is for less number of oxygen present. So here it will become sodium nitrite. Clear? 8 is for when more oxygen is there. Ite is for when less number of oxygen is present. We next come to the fourth kind. If still less number of oxygen is found in a compound, less than what? If still less number of oxygen, than ite. Okay? If still less number of oxygen than ite is found in a compound, like NaClO. Here it was 2, now here it is only 1. So when still less number of oxygen than ite is present, then how do we name it? Here also 3 elements are there, but oxygen is still less than ite. So here we are going to use the word hypo. Your prefix now here will be hypo. So the name becomes sodium hypo what? Chloride. After chloride, no, the chloride remains the same. Only the word hypo is added over here. I hope this is clear. Now, if more number of oxygen than 8 is present, then how are we going to write down? Then the prefix that is to be used over here will be your per. Like for example, NaClO4. Now nitrate is 3 and the oxygen is more than 3. Right? More number of oxygen than 8. Then what prefix are we going to write? Per. So what will be the name of this? Sodium per. This was 8. So I'm going to use over here chlorate. Did you get this? Did you understand this? Okay, I'm going to give you a very nice way of learning all. Take this example. Like NaClO, NaClO2, NaClO3, NaClO4. What have we learned? What did you learn about NaClO less than nitrite? It is sodium hypochlorite. This is sodium less number of oxygen. This was 2 over here, no? So sodium chlorite. Then 3 means 8. That means sodium chlorate. And if more number of oxygen than 8, then sodium perchlorate. See how easy it becomes to learn this sequence. So if I can change this sodium From here, if I write here K, then will you be able to give their names now? Then it becomes potassium hypochlorite, potassium chloride, potassium chlorate, potassium perchlorate. So simple it becomes. We next move to naming of the acids. We now move to naming of the acids. Naming of the acids. You know, acids are of two types. One is hydra acids and one is oxy acids. You must be wondering what are hydra and what are oxy. All those acids which do not contain oxygen, they are called as hydra acids. For example, HBr, HCl, right? And the acids which contain oxygen, they are called as oxy acids. For example, H2SO4, HNO3, or you may say H2CO3, and so on. So now how to name these kind of acids? So let's talk about first hydra acids. For example, HBr. How do we call them? What is their name? HCl or HI. Okay, so here the preference is given to hydrogen. Clear? And hence the name is like hydro. The word hydro is used. Bromic acid. The word acid comes at the end. Here hydrochloric acid. Okay, hydroiodic acid. So what did you see over here? The preference first is given to H, so that becomes your hydro. The next one is bromine. It becomes bromic. Chlorine becomes chloric. Iodine becomes iodic, and at the end we write down the acid. Now let us learn about oxy acids. H2SO4, HNO3 or H2CO3. How do we name them? Here we do not give preference to hydrogen. In fact, we give preference to what? Over here, the preference is given to this compound. Okay, this is highlighted over here. Right, the second group is highlighted. So give me the name of this. Sulfate. So what is the name? Sulfuric acid. What is this? Nitrate. So nitric acid. What is this? Carbonate. So carbonic acid. I hope till here everything is very clear to all of you. Next we come to naming of the bases. Now we are going to learn about how to name the bases. Naming of the bases. Bases, what are they? They are metallic hydroxides. They are metallic hydroxides. They are called as hydroxides after the name of the metal. Example, NaOH or KOH. So how do you name this? Sodium hydroxide, metallic hydroxide, sodium hydroxide. Clear? Potassium metallic hydroxide, potassium hydroxide. Right? Next we come to certain trivial names. What are trivial names? These are those compounds which have some common names. There are no certain systematic rule that is been assigned to such kind of compounds. Therefore, the name comes trivial names. For example, NH3. So, what is the name of this? Ammonia. Now, do you find any similarity between this and this? There is no systematic rule for giving the name to to NH3 as ammonia. So, bus NH3 is called as ammonia, NH3 is ammonia. Similarly, H2O. What do you call it as? Water. Clear? Though it is dihydrogen oxide, if you call it as a chemical name, but its trivial name is water. We next now come to, I hope naming of the chemical compound is very clear to all. Today I am going to send you certain assignments. Check it out in your file, fold off your assignment and do the needful in your register. Okay. We further move to chemical equations now. We move to chemical equations. Now, what are chemical equations? What are chemical equations? An equation is a statement that describes a chemical change in terms of a symbol and formula. So, this chemical equation, it has a reactant and also it has a product where the reactant changes into the product. Let's take an example like KClO3. This is a reactant. Okay. Then we have an arrow. Arrow has an arrowhead. This arrowhead shows in which direction the reaction is moving. And then we find these are the two products formed. Okay, so they are called as product. Thus, a chemical equation has a reactant and it has a product, and always a reactant changes into the product. This is very clear. Now, there are different types of chemical reactions that we are going to study just now. After that, we are also going to do the balancing. Today, we shall finish off with the chemical equations. So, what are the different types of chemical equations that we need to study? The first kind of chemical equation, it is decomposition reactions. Decomposition reactions. What do we mean by decomposition reaction? When one compound decomposes to give two or more products, then it is called as a decomposition reaction. Let's take certain examples. ZnNO3 whole twice. On heating, now this triangle means heat. Okay. So this forms ZnO plus 4NO2 plus O2. Do you think this equation is balanced? Let me check this 2. This I have written only 1. 3 to the 6. 4 to the 8. 9, 10. No, this is not balanced. So we write this 2 over here. We write this 2 over here. 2 zinc. 2 zinc. Okay, balancing we'll study later on. This much is very clear. Okay. Next, another example. CaCO3 on heating gives CaO plus CO2. Then NH4 whole twice Cr2O7 on heating gives Cr2O3, that is chromic oxide, plus nitrogen plus 4 molecules of water. Okay. So what did you observe over here? One compound on heating gives 2 or more products. Such reactions are called as decomposition reactions. The second kind is synthesis. Synthesis reaction is also called as direct combination reaction. Direct combination reaction. What does this direct combination reaction mean? Here A plus B, that is the two reactants, they combine to form a single product. Then it is termed as synthesis reaction. Let's check certain examples like C plus O2 gives CO2, right? Then N2 plus O2 gives 2NO. Okay, another example could be like NH3 plus HCl can give us NH4Cl, or maybe NO plus O2 will give 2NO2 over here, or maybe N2 plus 3H2 gives NH3. Now how much is this? 2. Okay, so such kind of reactions where only one product is formed, such reactions are called as synthesis or direct combination reaction. Next we come to third kind of a reaction. Where it is termed as double decomposition reactions. Okay, here what? Two reactants and two products are formed. These double decomposition reactions are of two types. One is called as neutralization reaction and the other one is called as precipitation reaction. Now, what is neutralization reaction? When acid and bases they combine to form salt and water, that is neutralization. What is precipitation? When a precipitate is formed, when an insoluble substance is formed, right? Then it is a precipitation reaction. So let's take certain examples like KOH. A base is treated with an acid, forms what? KCl, salt and water. Another example like NaOH treated with H2SO4 forms Na2SO4 plus H2O. So what did I tell you? What are neutralization reactions? When bases combine with acids, they form salt and water. Such reactions are called as neutralization reactions. Now let me tell you what are precipitation reactions. Like AgNO3 when treated with HCl will form AgCl plus HNO3. So here this AgCl is your precipitate and precipitates are always shown with a downward arrow. Another example could be like FeCl3 plus NaOH will give FeOH whole thrice plus NaCl. So here FeOH whole thrice is your precipitate. So such reactions, what are they? They are precipitation reactions. But neutralization or precipitation reactions, see here, double decomposition, two reactants forming two products. Okay, two reactants and two products. Clear? They come under this category. Now two reactant, two products, one more reaction comes under this category, that is called as displacement reaction. Displacement reaction. What is a displacement reaction? What is a displacement reaction? Anybody who remembers? Come on. CuSO4 plus Fe. Remember? Higher elements can replace the lower elements, but lower elements cannot replace the higher elements, and hence the reaction goes like it is going to, iron is placed above copper or below copper? Above copper, right? So it is going to displace copper and form FeSO4 plus what? Reddish brown deposits of copper will be formed. This is a displacement reaction. Clear? Another kind of a reaction where two reactants and 3 or 4 products are formed. 3 or 4 products are formed. They are also called as chemical equations. They do not have a specific name as I had given you as above, but yes, these are also kind of reactions. For example, CaCO3 plus HCl. What is it going to give us? It will give you CaCl2 plus H2O plus, it is a carbonate, so carbon dioxide will be given out. Same way, Na2SO3 plus H2SO4. What is this going to give us? Na2SO4 plus H2O. It is a sulfide, so it is going to give us sulfur dioxide. Clear? Another example, Pb3O4. Do you know what is Pb3O4 called as? Red lead. In general, the travel name is the red lead. And if you have seen the sindoor, the orange sindoor that mummies use during the puja time, that is Pb3O4. It combines with HCl and this forms PbCl2 plus Cl2 plus water. So what are these kind of reactions? These are also reactions which have 2 reactants and 3 or 4 products are formed. This was all about your chemical equations. Now we know the different types of chemical equations. What were they? Decomposition, synthesis, double decomposition. In double decomposition we have neutralization and precipitation, displacement reaction, and there are certain reactions where 2 reactants, they give us 3 or 4 products. Now let us move to balancing these equations. We are going to balance the equations. Now balancing the equation you have already done in your previous classes so many times. So just a recap. Okay, I am not going to give much time over here for your balancing. So a recap, balancing of a chemical equation. Okay, let's take N2 plus O2 gives NO. Now one thing is very important to be understood while balancing. Here in a compound we do not consider a compound as a whole while balancing. We need to use a different an element separately to balance. For example, nitrogen is here. How many nitrogen? 2. Here we have 1. Oxygen is 2. Here we have 1. Okay. So 2 nitrogen we require the reactant side. Oxygen side also we require 2. So what do we write? We write 2 in front of nitric oxide. So now it is balanced. 2 nitrogen, 2 nitrogen, 2 oxygen, 2 oxygen. Clear? Let's take another example. H2S plus sulfur will be formed. Fine. Now let us do this. Hydrogen 2, sulfur 1, sulfur 1. Oxygen how many? 2, but here it is only 1. So what are we going to do? We will write here 2. But when we write here 2, oxygen is balanced but your hydrogen is not balanced now. What happened to your hydrogen? 4. So I write here 2. Now 2 hydrogen. Okay. Now let's look at this. 2 to the 4 hydrogen, 2 to the 4 hydrogen. But how many sulfur now? 2. So write here 2. Oxygen how many? 2. 2. It is balanced. Followed? Take another one. KClO3. This on heating gives KCl plus O2. 1 potassium, 1 potassium, 1 chlorine, 1 chlorine. 3 oxygen here and 2 oxygen here. So what can I do? What can I do about this? 3. Now you are not going to insert any number in between. Remember, the number has to always be written in front of the compound. Okay. So what if I write 2 over here? So if I write 2 over here, it becomes 2 potassium. So if I write 2 potassium here, 2 potassium, 2 potassium, 2 chlorine, 2 chlorine, but oxygen 3 2s are 6. Oxygen is only 2 over here. If I write 3, 3 2s are 6. Is your equation balanced? Okay. Take another one. NH3 plus CuO gives N2 plus 3H2O plus 3Cu. With this is 3 and this becomes that. Thus balancing of a chemical equation conveys. What are they? It tells about the reactants taking part in the reaction. It also tells about the product that is forming during the chemical reaction. It tells the number of atoms of each element that is participating in the reaction. See, while balancing, we were just doing that accordingly. We were balancing the equation. It also tells us the number of molecules. Now look here, one molecule of nitrogen, one molecule of oxygen gives two molecules of nitric oxide. Got it? So it also tells the number of molecules of different substances that are taking part in the chemical equation. It also tells about the volumes of the gaseous reactants and the products. The volume of the gaseous reactants and the product. And last but not the least, it also tells us the masses of the reactants and the products included in the reaction, and they're always same. Do you remember any law? Law of conservation of mass. Okay. So let's take this. N2 plus O2 gives 2NO. Nitrogen, it is what is the atomic number or atomic mass of nitrogen? 14 into 2. This is 14 2s are 28. Oxygen is how much? 16 into 2. 16 2s are 32. Okay. These many grams. Add up this. How much does it become? 8 plus 2. 3, 4, 5, 6. Total is 60 grams this side. Now let's check this. Nitrogen is how much? 14 plus oxygen is how much? 16 multiplied by how much molecules? 2. So 2 into 6 for 30. How much does it come out? 60 grams. Got it? The reactant and the product side, they are always the same. But this chemical equation has certain limitation. It does not tell whether the reaction was going fast or slow. It did not even tell us or give us any idea about what pressure are we using here, whether we are using any temperature over here, what kind of a concentration has been used over here. It does not tell us the physical state of the reactants. To know the physical states, I need to write down gas over here. Otherwise, if I don't write, do you understand whether it is a liquid or a gas? No. So, the reaction does not even tell us the physical state of the reactants. And it also does not give us any indication regarding the evolution of the gas or absorption of the heat. So, all these limitations were overcome by different ways, like gases were written over here, or here the solid was given. Then if the gas is evolved, the arrow was given, right? So different limitations were overcome, but still the balancing of chemical equation has certain limitations. So today we wind up over here. I'll come up back to you tomorrow with more of part in the language of chemistry. Thank you.